Hello everyone, this is Professor Gautam from Sai Vidya Institute of Technology. I welcome you all for today's session. In this session, I am going to discuss about California bearing ratio test on soil. Now, before going into the problem, let us have a look on the formulas used in this test. Now, CBR is given by the formula load or pressure sustained by the specimen at 2.5 or 5 mm penetration divided by load or pressure sustained by standard aggregates at the corresponding level whole multiplied by 100. This denominator value, that means load or pressure sustained by the standard aggregate at the corresponding level, is given by at 2.5 mm penetration. You have to consider standard load as 1370 kg and pressure as 70 kg per centimeter square. At 5 mm penetration, we have to consider it as standard load 2055 kg and pressure as 105 kg per centimeter square. Now, with this, straight away we'll start the problem. Here the problem is the load penetration value of CBR test conducted on two specimens of a soil sample are given below. That means they had conducted CBR test for two soil sample and data they had tabulated as below. Here what they are asking is determine the CBR value of soil if 100 division of the load dial represents 190 kg load in the calibration chart. He has just given the calibration chart readings and is saying that scale will be 100 division represents 190 kg. Therefore, obviously, one division is equal to it represents 1.9 kg. It is just a scale conversion. Now let us see the data. What data they had given? They had given at different penetration levels what are all the load dial reading divisions recorded. At 0.5 mm penetration, dial reading will be here, it is 8, and here it is 0.5. Therefore, 8 division means you have to consider 1 division is equal to 1.9 kg. Therefore, 8 division stands for 8 into 1.9 kg. You have to do the conversion at the end. Okay. Now, what we have to do is we will plot a graph for penetration value and the load values of specimen number 1. And in the same graph, again, we will plot a graph on penetration in the x-axis and the load value in the y-axis for specimen number 2. Now, first let us plot a graph for column number 1 and column number 2. This penetration value you have to consider it in x-axis and this load value you have to consider it in y-axis. Okay, here you can see I had plotted the graph. I took the scale here, x-axis represents, I took the scale, x-axis represents 1 unit is equal to 0.5 mm, and I took the scale y-axis 1 unit is equal to 5 division. This is the scale I used. I repeat, in the x-axis I took the scale 1 unit represent 0.5 mm of penetration. In the y-axis 1 unit represents it is of 5 divisions. Now this is the curve represents for specimen number 1. This curve represents for specimen number 1. I just took the penetration value in the x-axis. You can see here for 0.5 mm penetration, load dial reading will be 8. I had marked here. Next, for 1 penetration, here it is a 1. For 1 penetration, I marked the division as 15. Next, for 1.5 penetration, I mark the division as 23. You can mark here. Similarly, for 2.5 mm penetration, I mark the division as 34. You can see here. For 5 mm penetration, I mark the division as 48. You can see here. Similarly, last point, for 12.5 mm penetration, I mark the division as 67. You can see here. Okay. Once it is done, you have to concentrate on two values, that is the value marked at 2.5 mm penetration, this is the value, and the value marked at 5 mm penetration, this is the value you have to give a concentration. Now what you have to do is you just project a line from 2.5 mm penetration like this to the curve and project back to the y-axis and note down this value, and this is equal to 34 division. Okay, similarly again at 5 mm penetration you just project a line like this and project back to y-axis and check out what is the value, this one, this is equal to 48 division. Okay, once you ready with this value, that means for specimen number 1 at 2.5 mm penetration it represents 34 division, at 5 mm penetration it represents 48 divisions. Once you ready with that value, you know the formula of CBR. CBR is equal to load or pressure sustained at 2.5 or 5 mm penetration divided by standard load. Standard load for 2.5 mm penetration is 1370 kg and standard load for 5 mm penetration is 2055 kg. You have to calculate the CBR value for both the penetration value. I just calculated here. CBR value at 2.5 mm penetration is equal to 64.6 divided by standard load is 1360. You may get the doubt how we got this 64.6. At 2.5 mm penetration, total number of divisions will be 34 as we obtained here. That 34 division equal to how much? One division represents 1.9 kg. Therefore, 34 multiplied by 1.9, that is equal to 64.6 kg. As per the CBR definition, CBR definition is equal, as per the CBR definition, CBR value at 2.5 mm penetration is equal to 64.6 divided by standard load at 2.5 mm penetration is 1370 whole multiplied 100. The CBR value of the soil is 4.7 percentage. Similarly, calculate for CBR value at 5 mm penetration. Number of divisions recorded at 5 mm penetration for specimen number 1 is 48. You just do that 48 divided by 48 multiplied by 1.9 into divided by a standard load is 2055 at the denominator. You have to substitute whole multiplied by 100 you have to do, and you are going to get CBR value for about 4.4 percentage. Now out of these two you have to consider the highest value, and always you will get more CBR value at 2.5 mm penetration itself if you do the experiment properly. Okay, now therefore CBR value of specimen number 1 is how much? 4.7 percentage. Okay, now repeat the steps for specimen number 2. Okay, here this curve indicates specimen number 2. This curve indicates for specimen number 2. Now let us see the specimen number 2 data. I will just show the points for 2-3 points. Okay, you can see here this is the specimen number 2. For 0.5 I marked it as 0.5 division only here. For 1 division I marked it as 1.5. Then for 1.5 division I marked it as 2.5 division. Then for 2.5 I marked it as 13 division. You can see here I marked it as 13 division. Next for 5 I marked the division as 38. You can see here I marked it as 38. Okay, similarly at last 12.5 I marked as 63 division. Okay, now here the problem is initially you can see the curve, it takes the concavity curve, correct? No, see initially it is concave, later it has went with an uniform texture, correct? No, because of this initial concavity you have to correct the curve like this, where the curve trend has been started uniformly you mark that point, from that point you just drop a tangent line like this. Okay, now from this point you have to consider 2.5 penetration. You can see here From this point, you have to consider 2.5 mm penetration. It will come around 4.1 or 4.2. Again, again, from this point, you have to consider 5 mm penetration. It may come up to 7.2. I hope you are getting the point what I am saying. When there is an initial concavity in the curve, where the curve has shown a uniform path, from that point you drop a back tangent, and you have to consider that point as an starting point or origin. From that point you have to consider 2.5 and 5 mm penetration value to get values in the y-axis. Okay, now from here to here, 2.5 means it is near to 4.2. From here you just project a line like this. Okay, and project back to y-axis like this, and you note down this value. Similarly, at 5 mm penetration means you have to calculate now at this point, project a line like this. Okay, and project back to y-axis and note down this value. Okay, I noted both the values here, and I had written here at 2.5 mm penetration it is 32 as we obtained, and at 5 mm penetration it is equal to 47 as we obtained here. Okay, now use the same formula. CBR at 2.5 mm penetration is equal to 61 divided by 1370. It is a standard load. How we got that 61 means I converted divisions into load value, that is 32 into 1.9, that is equal to 60.8. I took it as 61. 61 divided by 1370 multiplied by 100, that is equal to 4.45 percentage. Similarly, calculate it for 5 mm penetration, that is calculated as CBR at 5 mm penetration is equal to 89.3 divided by 2055 multiplied by 100. Okay, how we got this 89.3? 47 division we got it from the graph in the y-axis. Therefore 47 multiplied by 1.9, that is equal to 89.3. Therefore that is also equal to 4.3. Now CBR value, when comparing with CBR value at 2.5 and 5 mm penetration, we have a greater value at 2.5 mm penetration. Therefore what we did is correct. You consider for specimen number 2 CBR value as 4.45 percentage. Now in order to calculate CBR value of the soil, just take the average of specimen number 1, that is 4.7, and specimen number 2 is 4.45 divided by 2. So I'm going to take an average value of specimen number 1 and 2 to finalize the CBR value of soil. Now at the end, CBR value of the soil is how much? 4.6 percentage. And this is how you need to calculate CBR value of the soil. Guys, I hope you understood today's class. Thank you so much, guys. We will meet in the next session with another problem.